Today's lesson is about solving absolute value inequalities. So a few lessons ago we had compound inequalities, if you remember, which had an and or an or. If you have an inequality and there's an absolute value sign in it, you'll find it will also end up being an and or an or. It'll also be a compound inequality. So let's start straight away with some examples. And I'll take you through all of these step by step. For all of these, I'm actually going to ask you to solve and graph. It'll be a lot more helpful for you to rewrite your final answer in the end when you graph it. My first example, I have the absolute value of x is less than or equal to 2. And there's two ways that you can look at this. I'm going to show you the way that you can kind of think about it by looking at a graph, and then I'm going to show you the way that will work for all of these. So what we're going to do is we are going to think about what does absolute value actually mean. So what this means is that the distance of x from 0 is within 2. It's less than or equal to 2. So if you were to graph it, we would know, if we have 0 here, that x can be all of the possible values that are within 2 of 0. So x can be anything that is left to the 2 to the left of 0, and anything that is 2 to the right of 0. And it's greater than or equal to, so it's going to be a closed circle. So we know that our answer would be -2 is less than or equal to x is less than or equal to 2. Unfortunately, it's not always that easy to see, and if it was confusing for you when I just did that, it might not have been easy to see at all. So we have a way that's going to work for all of these problems that you don't have to graph it all the time. Although in this case, I'm going to ask you to graph it all the time, but you'll actually just be able to work the problem out. So the other way that you can do this is you can take this problem and split it up into 2, the same way that you did when you were working with absolute value equations. What you can do is you just rewrite the entire equation, the entire inequality, without the absolute value bars. X is less than or equal to 2. The second one, though, is a little bit more complicated. So you're going to keep the x the same. The sign, the inequality sign, is going to change to greater than or equal to. And the 2 is now going to become negative. So there's two things that we just changed. So I'll recap here. So on your second one, you are going to reverse the inequality sign and make this negative. On the first thing, everything is going to stay the same. So nothing changes from the original. The original absolute value of x is less than or equal to 2. So nothing changes from the original. Except that your absolute value bars are gone. So you either change nothing or you change two things. Keep that in mind as you're doing it. So the other thing I want you to know is if you see less than or equal to, that is always going to be an and inequality. So less than or equal to is an and. So if you have anything less than or equal to, it's and. If you remember when we had and inequalities, we always combine them into 1. So in the end, you're going to take these and combine them into 1. And when we combine into 1, we always put them in order from the smallest to the largest. So the negative is the smallest, the positive is the largest, the x goes in the middle. So easy way to look at the first thing, the x is greater than or equal to 2, you just rewrite that right there. X is greater than or equal to 2. On the second one, x is greater than or equal to -2, we actually have to switch around the sign to show that that's true. And that's my answer. You'll notice it's the same as the answer I got on the left-hand side. So the explanation for the last one I know was really, really super long. So if you want for this one, if you feel comfortable about it, you can feel free to try this one on your own and pause it, or you can just watch me do this one. So for this one, we are going to start, I'm going to just split it into 2. And I'm going to get x is less than 3. Remember, the first one, don't change anything. And I'm also going to get x is greater than negative 3. Don't forget you change both the inequality sign and you make it negative. Also, because this is a less than, once again, so I have absolute value is less than or equal to is the same. It's an and, which means that in the end, I do need to combine them together. So when I combine them, I am going to start by writing them in order. X is less than 3. I know that's true. X is greater than negative 3, so I need to write that like that. This is my answer. Now, I did ask you to graph everything, so please do graph this one. So we know that we have open circle at negative 3, open circle at 3, everything in the middle, and that's my answer. So number 3, I'm going to have a greater than. And you might be able to guess, if I have x is less than, we know that it's an and. If I have x is greater than, you will find out when you have absolute value of x is greater than, or absolute value of x is greater than or equal to, that it's going to be an or. So you'll see this in the end, by the way, when you look at the pictures. If you look back at 1 and 2, the absolute value graph, it was 2 dots on the end, everything shaded in the middle. That was what the and inequalities look like from section 5.4. And you'll find that these look similar. These look similar to 5.4 when we have the or inequalities. They went into 2 different directions. You'll see that in this one. That'll help you check and make sure you're doing it right. So I am going to split this up into 2, just as I did before. I get x is greater than 1. Also, remember, x less than negative 1. And it's an or, so I'm going to write the or in the middle. If you forget that it's an or, you can always graph it and then go back and rewrite that. So I start with my x is greater than negative 1. I'm going to use an open circle. Greater than means I go to the left. Then I'm going to do x is less than negative 1. Open circle, go to the left. I think I said right when I said left when I should have said right in the previous one. So this is what my graph looks like. And as we had in 5.4, it is an or. You'll notice that ors go in 2 different directions. So let's go on to some that are a little more complicated now. I'm going to get the absolute value of x plus 2 is greater than 1. So if you have an absolute value is greater than, this is going to be an or inequality. If you had less than, it would have been an and. We're going to start by splitting it up into 2. So when I split into 2, I get x plus 2 is greater than 1. My first one, I change nothing. The second thing I get when I split it, I change 2 things. I change my sign, it's less than now. I make it negative 2. Now I'm going to solve each of these inequalities individually. I start by subtracting 2 from both sides. I end up getting that x is greater than negative 1. This one I start by subtracting 2 from both sides. I get x is less than negative 3. Since it's an or, I'm going to write my or in. Don't forget to do that in the end of the problem on your test or quiz. I usually take off a half or a quarter of a point for that. Not a big deduction, but it's nice to not miss little points like that. So I'm going to go ahead and draw my number line. I start with x is greater than -1. I start at -1 with an open circle. Greater than means I go to the right. I also have x is less than -3. Less than means I go to the left. Since it's an or, you'll notice that I have arrows going in opposite directions. That is a good sign. Usually I can tell right away if the arrows go in the same direction. That means I made a mistake. All right, here is another fun one. So you need to start, as with inequalities, by getting the whole thing as with the equations, you get the whole absolute value by itself. So get this by itself first. I'm going to move over the 4 by adding it to both sides. I end up getting the absolute value of 2x plus 3 is less than or equal to 9. Next thing I need to do is to split it up into 2. By the way, at this point you can look and see what type of inequality it is. Its absolute value is less than, which means it's an and. So I'm going to split it up as 2x plus 3 is less than or equal to 9. You change nothing except for taking out the bars. And I have 2x plus 3 is greater than or equal to -9. So change 2 things there. From there, you're going to solve this whole thing out. I end up getting 2x is less than or equal to 6. In the end, I get x is less than or equal to 3. Same thing here, I get 2x is greater than or equal to -12, which gives me x is greater than or equal to -6. So this one is an and. When I have an and, I need to put them together as 1. So put them in order. -6 is first, 3 is the last, the x is in the middle. I know that x is less than or equal to 3. X is greater than or equal to -6, so I'm going to show that by moving around my sign. This is my answer. Okay, 6 is my bonus one that I am only going to give to honors, and with CP it will be a bonus only. So if you're CP, you can fast forward through this one to 7 and 8. If you are honors, I still want you to do this. However, if you're CP, I do recommend that you do this because you might have a bonus like this on your test or quiz. I'm going to start by adding 13 to both sides. So once again, I need to get the bars by themselves. Everything there has to be alone. I end up getting 2 times the absolute value of 3x plus 8 is less than 8. Then I need to get rid of that 2 by dividing both sides by 2. So now I forgot a bar. Now I need to split this up into 2. First thing is 3x plus 8 is less than 4. The second part is 3x plus 8 is greater than -4. Now I'm going to solve this out like I would solve any inequality. I get 3x is less than -4. And you'll notice on this one, it is going to be a fraction in the end. That's okay. I end up getting x is less than -4/3. That's the first part. So the second part, I'm going to actually rewrite it on the side so I have more room. I will subtract 8 from both sides. I get 3x is greater than -12, which gives me x is greater than -4. So if you notice back on this part right here, I had the absolute value was less than, which means that it's an and. And don't forget with an and, you need to make sure that you write it as one inequality, So I start with my -4. I end with my -4/3. Put the x in the middle. This is going to be less than, this is going to be less than, and that's my answer for that one. Okay, my last two types are what we call a special case. So I have the absolute value of x plus 1 is greater than -1. So I want you to think about absolute value is anything you have in there. If you've solved for your absolute value bars, we know that this thing is always going to be positive. What that means is that no matter what I put in for my x, I'm always going to get a positive number out. And actually, positive numbers are always going to be greater than -1. So we know that this inequality is going to be always true. Because no matter what you put in, you'll get a positive number, and it's always bigger than -1. Positives are always bigger than negatives. Since it's always true, we are going to say that the answer is all real numbers. So that's where you're going to say the answer is all real numbers. A second special case is similar, except I switched around the sign. So once again, I know that the absolute value of x plus 1 is always going to be positive. As I said before, it's always positive. So a positive number less than -1. There's nothing that you can possibly put in for x so that you can get an equation, an inequality that works out and is true. This one, you're going to get a positive is less than -1. That's never going to be true. So this one is always false. When we have an equation or inequality that's always false, that means that our answer is going to be no solution. And once again, if you're a little lazy, feel free to draw a 0 with a line through it instead of writing out the words no solution. With all real numbers, there's not really an easy way to abbreviate it. You can say all reals if you want to. That also works. So those are our two special cases. I do like to throw a few of these into every quiz or test on this section, so just make sure you're aware of these.